Identify a pair of congruent figures. Determine the congruent transformation that maps the pre-image to the congruent image. To cast a reflection, you need a line of reflection. The distance from one point to the line of reflection must be the same distance on each side. If you look at all three lines, you'll find that figure AB and figure EF are congruent. The line of reflection would be Y1. B and E are each 1 point away from Y1, and A and F are each 4 points away from Y1. So your two congruent figures are AB and FE. Your congruence transformation would be capital R, which stands for reflection, y equals 1.
To perform a rotation, you must first determine which figure or figures you will be rotating. Next, you need to find the coordinates of all the points on the figure. When rotating a figure, use the following rules. When rotating 90 degrees, the coordinates will become negative y, x. When rotating 180, the coordinates will become negative x, negative y. When rotating 270, the coordinates will become y, negative x. And when rotating 360, coordinates will become x, y. So, if you find the coordinates of figure FGHI, then translate them to a rotation of 270, which will be changing them all to y, negative x. You'll get your new coordinates, and then you just need to graph them. And you just
Problems require two transformations like in this one. Now, because triangle EWT lies above triangle JQV on the plane, a translation can map triangle JKJQV up on the plane. Also notice that triangle EWT is on the opposite side of the y-axis and has the opposite orientation of triangle JQV. I suggest that a triangle is reflected across the y-axis. A translation of triangle JQV goes up 5 units. This will be followed by a reflection across the y-axis, which maps triangle JQV to triangle EWT. But first, we must first say that how we got our translation of 5 units. We will be reflecting across the y-axis. Right here, which you can tell just by looking at it will get us to EWT. And that's how you solve a double transformation problem.